Now I'll just choose this as my reason to add in one more piece of notation, which is not really another piece. But see how you kind of, I don't know about you, you might be getting sick of writing C's. They're everywhere and they kind of just clog up what you're writing. So there is another way to write this, which just retains the important parts, the numbers, okay? But it does look a bit weird the first time you see it. Okay, so I'm going to write it just above so you can see what's happening. Instead of writing nCr, we write it in a set of brackets like this. The important numbers are the N and the R. Well, they're not the important numbers, they're the only numbers. C is not a number. Okay? So I read this as 6C0, and 6C1, and 6C2. It's a bit quicker to write, and it is clearer because there aren't so many letters flying around. Okay. So it does. On the basis of this, I could, for instance, write out Pascal's triangle completely using this notation. Okay, for instance, the top row is, what number row is it, the top one? It's the 0th row, right? So it's 0, choose 0. And then the next row down, your row is 1, so it'll be 1, choose 0, 1, choose 1. And then it's going to be 2, choose 0, 2, choose 1, 2, choose 2. And then 3, 0, 3, 1, 3, 2, 3, no, 3, hold on, what have I done? Yeah, I just haven't gone far enough. Yeah. Sorry, this guy should just be further over. Okay, now there are some interesting things you can see when you start to write things like this. For instance, one of the properties that I did not name, but you can almost kind of see here, right, is how is Pascal's triangle formed? How is it formed? The first time you learn about it, you just form it by addition, don't you? Right? So for instance, you can see here that, I'll just pick out a random one. How about this guy? 2C0 plus 2C1 should be equal to this guy, right? They sort of go in like that. Yes? 3C1. That's how I get that number, right? I add up the two ones above me and they come down and they become, so this would be 1 plus 2 equals 3. That's what it's actually equal to. Now that's one particular case, but how do I state that in general terms? There's a couple of different ways to say this. Okay, for instance, if I say, all right, n choose r, I'm in the nth row, I pick the rth term, what's the next one over?
N plus 1.
It'll be nCr plus 1. Yes? What's that equal to? Well, I have to go down a row, which means I'm not in row n anymore. I'm in row n plus 1. Right? Which term am I after? It'll be the r plus, it's gonna, this number matches here, doesn't it? Can you see the pattern? So it's gonna be the r plus 1th term. And you can generalize that. This identity is so important, it goes in here, it'd be number 4. It's called, surprisingly, Pascal's identity. Okay? Because it shows this. Okay? It's from that structure.